So you guys probably heard a lot about AI today already, and now you are going to hear my take as well. So I hope you find something interesting. Hopefully, something will be the same and something different, right? I think that AI is with database is very fascinating topic those days. It is very broad, really. You can see what AI is really getting involved with any aspect of a databases, and AI is so moving also so fast, right? I did a similar presentation a year ago, and I had to really revisit a lot of things that I'm going to talk about. And I think which is very interesting in this case, what when it comes to AI at databases, there are so many perspectives in that case, depending on what your job is. Some people find that exciting. Some people find that challenging. Maybe worried about is that going to replace their job or make it better. So let's talk about overall about AI of data and databases. And I thought it would be interesting to talk about those, what does it say, six different areas in which we often talk about AI and specifically in this case with connection to the analytical databases and how that all plays together. So let's talk about the storage. So as I was preparing for this, I thought it would be good to go to AI and really ask what some of the state of art AI tools, LLMs, are really thinking about what storage choices would be good. And you can see it gives us a lot of choices in this case. And I think it's interesting what their file format as a Parquet and Apache Iceberg is mentioned here. That is indeed where we see a lot of traction, not just related to AI, but overall data storage and processing, because that is just so flexible. But of course, really, all those advices, what we talk about, they are really kind of incomplete because when you talk about data, there is a lot of different data which we deal with, and often that has to be stored in a different way. For example, when we talk about unstructured data, think about your videos, images, right? That's probably would be some of the most unstructured data out there. Typically, it finds its way in some sort of S3 or comparable storage, right? It feels very well out there. It doesn't need very much a classical database. But then we have the metadata, right? Typically, for the same unstructured data, we want to have some metadata to describe it. That's finds a much better way in the various databases, and that's where we often would want to process using the classical, tools like SQL queries. Then there is a lot of data in this world which is structured, and even more so with that you can see a specific formats. Right. For example, there is a lot of databases those days which are focused specifically on time series formats, which are optimized for the storage and the queries interface of that data is used. The other question which comes in data storage is to really think about the scale and a type of training which want to apply in our environment. Now, if you are reading the articles in a text sphere, you'll probably find a lot information about how companies like OpenAI or Meta are doing those like extreme scale training. And that is awesome, right? When you are really looking at those like petabytes of data, there is hundreds of thousands of GPUs, the costs of those trainings are reported into being hundreds of millions of dollars, right? That is very cool, but that is also something which we do not really, most of companies don't have to deal that stuff because that is a very expensive. And what a lot of companies need to do, that is something different, right? We often should rather focus on fine tuning and domain specific training. Here is how you can think about that. If you look about the training model from scratch, that would be, let's say, OpenAI creating GPT-5 base model, right? And that is absolutely massive and expensive and expensive. And then often you would have something like fine tuning for behavior. That's when we can get a GPT-5 based model and turn that into the chat GPT, kind of let that to be optimized for the communication through a chat method rather than doing other things. GPT-5 based model is also capable of doing that. And then also you often would have a domain specific training. For example, in the same space, you can think solutions like, legal GPT or code llama, right, which are focused on domain specific things, such as a legal industry or being familiar with the code. And that is something which is a lot more companies have to deal with. Now, what is interesting is we are seeing a lot of development in that space because what we want is to have more flexibility without the costs which come with, with tuning, right? Even if you for a large model, and that is where we can see the concept like adapter-based models, which really make the tuning even more efficient. Then you can think about what does happen inside their database and what database need to really support AI applications. And I think this is very interesting what we can see as a transition. A lot of things started with adding support of the vector data type and indexing, right? That is essentially like a core of AI support, right? Which we can see over the last 5 years or so, almost every database has added some sort of that solution. But when they figure out if you really want to build the database applications effectively with a database, maybe we need more than that. And we are starting to build on that foundation, right? We're seeing the databases starting to support in database embedding generation. Then you can basically call the database function to generate embedding based on text, for example, instead of having to do that in your Python and then just stick embedding in a database. We have features inside of a database specifically, such as supporting semantic search and hybrid search, right? Or implementing RAG, retrieval augmented generation, which is like inside the database rather than having to do that externally, right? And some other things. These, what I said, correspond to LLM specifically, but I think there is good to remember that there is still a lot which can be done with sort of like a classical AI. AI, as we used to understand that, let's say 5 years ago, like, hey, we are going to do some machine learning, we're going to do anomaly detections, we're going to, do some prediction of a time series and so on and so forth, right? All of those features are also being increasingly added to their database. The next thing, if you think about this database revolution or LLM revolution recently, is really about the natural language interfacing. That is what made chat awesome because it's so natural and everybody, even people who are not familiar with technology, can really get that. And now we are looking at the same way as a natural language interface and being applied to everything, including the databases, right? We are seeing a lot of development being done in supporting AI agents, right? For example, through implementing MCP servers for, everything, right? You can see every database out there have MCP server these days, so maybe even multiple variants. And we can see those being used for management and maintenance as well as for querying. What I think is also interesting in this case, if you are a developer or if you are in operations, you often see the database as a broad part of your infrastructure. And we are still building out the tools which say, hey, you know what? I want to not just look at my database, but look at that and work with it in the context of all the infrastructure. If you speak about natural language querying, something as a text to SQL has become its own industry, and you can see a lot of benchmarks in terms of how good different models can create the query based on your textual description. And we see some people having success with that, but it's also kind of hit and miss, especially for the most complicated queries. Then you can think about how AI is used for operations. Here we can have two approaches. One, and that was developed for a while, is developing AI inside the database kernel. And then there is one, then we have a AI sort of kind of as external AI DBA, which uses standard database, which is not particularly smart in AI concept, but which you can deal with that. And I think this is very interesting approach because we see what AI world is moving very fast, while AI is very conservative. If you think about many classical databases, MySQL, Oracle, Postgres, right? They classically have rather old, decades old code base, right? And they move relatively slow. So if you think about what can be done inside the database, I found that's very interesting because in research, there is so much cool stuff. You can see learned indexes and cardinality estimates. You can see a lot of awesome stuff which can be done with AI optimizer, after indexing, various like adaptive algorithms, after tuning, using AI to predict, contention between queries, security, and more, right? But if you look at the practice for most databases we are working today, they only implement really the tip of the iceberg of what is possible, what have been proven to work in research. And I think that is a very interesting time because that means there's like so much opportunity for engineers of the next years, next decades, to really take those things which are shown to be possible in research and take them inside the database kernel. Because inside the database kernel, that is where you can take decisions fastest. That's where you can have all information at your fingertips compared to sort of like an external solutions, right? Which don't have as much information and obviously have to operate with added latency. Now let's take a look at some external solutions. With external solutions, we see tools for configuration tuning, query tuning, and even kind of more general solutions like Oracle for years had this kind of autonomous database. But I think this is also the rule as it goes with AI. The more ambitious marketing claims, typically the more the difference between the reality, right, and the promise. So let's look at some tools which exist out there. Like one to mention would be the, dbTune. That is AI-powered optimizer for Postgres database, right? It's focused on the configuration tuning. Then there is, you can find a similar tool called Relim, which does similar things for MySQL, though it's also focused on queries. You can also find some query optimizers from companies like Avian, which has a free SQL optimizer, and they have like a more robust integration if you are their customer, right? Because uh, in reality, to do the query optimization, you need more than a query. You need information about indexes, cardinality, and so on and so forth, right? So to really get everything, you need to get more than a query a lot, right? There are some tools which go even further here, like Kahoot, which is not just a database tool, but that is a tool which looks at all your infrastructure, and it can help you with resolving problems, including the database problems. One thing which I wanted to show you here, and I think why I pointed out earlier on, the database is only part of your of a database is what problems with database are not always a database. In so many cases, we can see some new application deploys which has some new queries or some other bad code which just tends to overload the database, and that's very well maybe the root cause, right? Like in this case, we can see what the deployment of a new code just happened to overload the database, and solution maybe actually to roll back that code, right, and then dig in more details. Now, the next, besides the operations, is using AI for development of applications which are using their database. And that is where you can see a lot of different things which are being used, right? You can see AI can now be used to design a schema, can use to help you with design SQL queries, query improvements, and index recommendation. One tool which I found particularly interesting, used by a lot of the junior developers, when you can say, well, I get this explain statement from my database, and there is so much stuff here I don't understand, right? But you can ask AI tool to to help me to understand that, right? And the other thing which I also find, as somebody who is a big fan of benchmarks, is using AI for synthetic data creation, right? Because if you look at that, if you want repeatable benchmarks, especially benchmarks shared with public, we cannot use our real customer data, right? That's, wouldn't work very well. And at the same time, when we just go and manually create the data, it's often became, so not representative, right? Like if you just, all the name in a database is a Joe Doe, well, it wouldn't work, right? Your compression, cardinality, right, whatever wouldn't work differently. And AI can really help us to generate the data, which very much looks like a real thing, but it is also, really not sensitive. So I think that is a very, very cool. Okay, so here are some the examples, right, of a tool, right, which can help you to generate complex SQL in 10 seconds, no coding required. Actually, you can find those tools out. There is a lot of tools out there. Some of them are standalone. Some of them are integrated with a lot of platforms out there. And as I mentioned, that is something which is still being in development. Okay. Now let's talk about analysis and visualization. I think that is also where AI can be very helpful. We see a lot of people using AI very successful with data preparation and cleanup, especially if the data is not particularly clean. AI can be very, very good. Now, there are also a lot of tools how you can ask AI to help you with visualization and dashboard creation those days, if again, either through human language integration or from coding tool support. And I think what we found also very good is what AI is getting very good explaining meaning of data and potential cause of something, right? In many cases, you can, even go as far as give a screenshot of some graph and say, hey, what is going on here? right? And it can create some fears. And of course, if you have a AI which is built into the tool, right, it can get much more background and provide the optimization, provide you some ideas. I would really look at that, but also be careful because uh, uh, yeah, there is still certain amount of unexpected mistakes AI can do. One interesting conversation I had recently is I spoke to relatively, for um, a junior data analyst, and was saying, "Hey, aren't you worried about you losing your job?" He was saying, "Me, in our company, our data is such a mess. For now, AI kind of really deal with that, right? Because in many cases we need to really go to the people and actually understand. Okay, well, this thing the column says it's X, but it doesn't look like it, right? What does that really mean? And I frankly think what he is mistaken. But so far, I think that is where dealing with a mess. That is where you often find some humans needed. The last thing I wanted to touch on their data and analysis in this kind of DIKW term, right? I think this is a very interesting concept how you can think about their data. And some people also get this inside as a separate item here, right? And I think that is a very valuable. We can see what the data on its own. Well, that is a just data, right? Which in requires some additional metadata about what that means, right? That's to say, well, you know what? We need to know what that sort of like a column is to really be using that property, right? Then often you can think about the knowledge, right? What does that really means and why, right? And then you can see the insight, what that really means, right? And then some people talk about wisdom. Okay, how can we really use that for our business, right, or our life to do it. And I think this is a very interesting framework, right, because that allows us to see is okay, like where in those areas we can use AI, where it fits better, and where it doesn't work so far. Okay, so here are some final thoughts I want to leave you with. As I mentioned, I think is a very interesting what we see right now, where we have like extremely high-paced AI world is sort of like a clash with our slow-moving worlds of databases. And I think there is still a lot of uncertainty how exactly industry will evolve and how quickly, right? I mean, we already have seen that in certain cases. Like, I mean, I remember Boris probably 15 years ago we were promised full autonomous driving car availability in 5 years or so, right? Well, you know, still getting kind of closer, but it's still not quite there, right? So the question in this case is, are we going to get the self-driving database, completely not requiring human in any case in the next couple of years? Maybe, maybe not, right? It's kind of hard to predict that. But I think what is important here is I think is no matter what your job is, I would suggest you to track how the AI capabilities are evolving, because at the very least it helps you to do it more, do it faster, better, and hopefully more fun. And with that, that's all I had to say. Thank you.